Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the derivative of these exponential functions. So let's start with the first function. So the first function is y equals 400 times 2 to the power x plus 3. So this function has an exponential term 2 to the power x plus 3, and the base of this exponential term is 2. So it is not e, the Euler's number. So the derivative of this function will be, so y prime equals, now 400 is a constant and it's the coefficient of this exponential term, so it will stay as it is. Now the base of this exponential term is 2, so its derivative will be the term itself times ln of the base, which is 2, times the derivative of the exponent, and the exponent of this term is x plus 3, and the derivative of x plus 3 is 1 plus 0. The derivative of x is 1 and 3 is a constant, so its derivative is 0. Now we can simplify this expression. Now in the parentheses, 1 plus 0 is equal to 1, and it won't change anything because multiplication by 1 doesn't change the term. So now we can rewrite this as, so this should be the final answer for the derivative of the first function. Now we can analyze the second function. Now the second function is made up of two types of functions. So x to the power 5, which is a polynomial function, and then 5 to the power x, which is the exponential function with the base 5. And since these functions are being multiplied, we'll have to use product rule. So the first step is, so we start with the derivative of the first function, and the derivative of x to the power 5 is 5, and then we subtract 1 from 5 in the exponent. So this is as per the power rule, times the second function plus the first function times the derivative of the second function. Now this is an exponential term, so the derivative will be the term itself as it is, times ln of the base, which is 5, times the derivative of the exponent, which is x, so the derivative of x is 1. Now we can simplify this expression. So in the first part, we can subtract 5 and 1 times 5 to the power x. Now in the second part, so ln 5 times 1 is just ln 5. So we just get ln 5. So we're using the parentheses to separate the terms from each other. Now we can do common factoring from this expression to simplify it. So we can factor out 5 to the power x. So we are left with so this can be the final answer for this function, or we can even simplify it more by factoring out x to the power 4 from both terms in the parentheses. So if we do that, we get So this can also be the final answer for this problem. So now we can analyze the third function. So the third function is y equals x times 3 to the power x squared. So this function is made up of two functions. One is the x, the polynomial function, and then the exponential function 3 to the power x squared. So we can use product rule because these two functions are being multiplied. So we start with the derivative of the first function. So the derivative of x is 1 times plus the first function times the derivative of the second function. Now this is an exponential term with a base 3. So the derivative is the exponential term itself times ln of the base times the derivative of the exponent. And the exponent is x squared. So the derivative of x squared as per the power rule is 2x. Now we can simplify this expression. So 1 times 3 to the power x squared is 3 to the power x squared plus, now in the second part, so we can multiply x in the front by 2x at the end. So it becomes 2x squared and then 3 to the power x squared and then ln 3. So we should use the parentheses to separate the terms. So to separate 3 to the power x squared from ln 3 and 2x squared. Now we can simplify this expression by factoring out 3 to the power x squared. So we are doing common factoring. So this can be the final answer for the derivative of the third function. Now we can analyze the fourth function, which is v equals 2 to the power t over t. Now this function is given to us in the form of a fraction. So there's an exponential term in the numerator and a polynomial term in the denominator. So we can use quotient rule to find its derivative. So v prime. So as per the quotient rule, we start with the derivative of the numerator term. The numerator term is 2 to the power t. So the derivative will be the term itself times ln of the base of the term times the derivative of the exponent. So the exponent is t, so its derivative is 1 minus, times the denominator term, then minus the numerator term times the derivative of the denominator. So the derivative of the denominator t is 1 over the square of the denominator. Now we can simplify the numerator. So 1 times t is just t, so we get 2 to the power t times ln 2 times t minus 2 to the power t over t squared. Now we can simplify this expression by factoring out 2 to the power t from the numerator. So we get ln 2 times t minus 1 over t squared. So this can be the final answer for the derivative of this expression. So now we are done with the fourth function. So now we can analyze the fifth one. So the given function is f at x equals square root of 3 to the power x over x squared. Now this function has a radical term in the numerator. So the first thing we should do is to change the radical into a rational exponent. So we get, so square root can be written as rational exponent 1 over 2. Now in the numerator we have a case of power on a power. So we can use the power on a power law of exponent and multiply the exponent. So we can multiply x by half. So we get, so 3 to the power half x over x squared. Now we can find the derivative of this function, and we can use the quotient rule because this expression is in the form of a fraction. So as per the quotient rule, so we start with the derivative of the numerator. So the numerator is an exponential term with a base 3. So the derivative is the exponential term itself times ln of the base, which is 3, times the derivative of the exponent. Now in the exponent, 1 over 2 is the coefficient, so it will stay as it is, and the derivative of x is 1, times the denominator, which is x squared, and minus the numerator term times the derivative of the denominator, and as per the power rule, the derivative of x squared is 2x over the square of the denominator. Now we can simplify the numerator. Now in the numerator, in the first part, half times 1 is just half. So we can simplify this as times ln 3 times, and then half times x squared is half x squared. Then minus, then in the second part, so we can just do 2x times over, now in the denominator, we can multiply the exponents because it's a case of power on a power. So 2 times 2 is 4. Now we can simplify this expression by doing common factoring in the numerator. So in the numerator, we can factor out 3 to the power half x and then x from both terms. And we are left with ln 3 times 1 over 2 x and then minus 2 over x to the power 4. Now we can simplify this further by cancelling out one of the x's from the numerator and the denominator. So this x and one of the x's here cancelled out. So we can rewrite this as, now 3 to the power half x can be rewritten as the term in its original form, so square root of 3 to the power x. So we changed the radical to the rational exponent to make it easy to find the derivative. And then, so it will be half x times ln 3 and minus 2 over x cubed. So this can be the final answer for the derivative of this fifth function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.